Nice. I posted a link on my Facebook today that showed how to make a low-pass filter, and it's really simple. It's here we got here is a 1 microfarad capacitor and a 1K resistor. And what this acts as is like a nice low-pass filter. You can hear it now. I've got a little jumper. I'm going to put the positive to bypass the resistor. And listen to the difference. Hear that? Cool. And so what this does, let me reverse engineer this. This is the output to the speaker here, the blue and the white. And we've got our little 1 microfarad capacitor. It's 50 volts. I don't know if the voltage is more important. At least you've got to have enough volts to handle the voltage you're putting in. And then we get a 1K resistor that's coming from the positive of the audio source into the positive of a capacitor, with the negative going to the negative of the audio source. And then it's simply a matter of plugging in speakers or running it out to an amplifier. And the negative goes to the negative and the positive goes to the other end of the resistor or the other side of the capacitor. There we go. Now we get our low pass filter running. Get my jumper and show you once again. There's the positive, and now we're bypassing the resistor there. Cool. Anyways, it looks like a pretty simple thing. There's a formula for calculating the value of the resistors and the capacitor to separate different frequencies. This is all for a project that I want to use for an RGB LED being run from an Arduino. I want to build 3 bandpass filters, a low, a mid, and a high, and then use that to control the red, the blue, and the green. It'd be very cool. This is a nice start. Okay, now I've got it coming out of the laptop into the board, into the bandpass filter, with the negative into the negative of the capacitor, the negative of the audio output going back into the input, auxiliary input of the amp, coming out the speakers, and the positive of the input going into the auxiliary is coming from the positive of the capacitor. On that same rail, the positive, we've got a 1K resistor connected to the positive of the audio out from the laptop, and the negative out from the audio of the laptop into the negative of the capacitor. And you'll hear as I unshort this from the resistor or unconnect it. Wrong spot. Right now we've got a low pass filter working, and then here's the difference. Come on. There we go. See that? Very cool. This is like so simple. And that's called resistance capacitance, or an RC filter. Sweet. Here's a little diagram. Got an input from like an MP3 player, positive and negative. The positive goes through a 1K resistor into the positive of a capacitor, and that's the positive output on the other side. The negative of the MP3 player, or the audio source, goes into the negative of the capacitor and the negative of the output. So what happens is the resistor is somehow blocking how fast this capacitor can charge and hold current. Something it's interesting anyways. That's a 150 hertz low pass filter, which is a 1K resistor and a 1 microfarad capacitor. There's different ways to do it. There's a schematic of it. And this is a high pass filter. And in this case what we're doing is, from the positive we go into, let's see here, I'm not sure about that one. Negative, probably into the positive of the capacitor, the negative of the capacitor coming out into series to ground with a 10K resistor. So we're flipping the resistor and the capacitor around, and then you can get a high pass filter. Alrighty, okay. So just added a variable resistor here to this, and now I can control. try some different values of capacitors next. See what more microfarads does, or what even picofarads do. So heat them on. Not sure if this is valid or useful to anyone, but I noticed that when I place a capacitor in directly in line with audio in and out, that's connected straight from the output of the laptop into the auxiliary into the amp. If I put on the negative and the positive in parallel a capacitor, listen, hear that? Big time filtered. And it sounds pretty clean, and that's without using a resistor. That's using a 10 UF 50 volt. Nice. So we'll call that a C filter. Forget the L or the I. I is for inductance. L is for inductance. I is current. We'll see you soon.